Welcome to our video on communication systems. Let's dive right in by understanding the two main types, digital and analog communication systems. Digital communication systems transmit data in the form of binary codes, ones and zeros. They include key components like the transmitter, which encodes and sends the data, the channel, which carries the signal, and the receiver, which decodes the data. Analog communication systems, on the other hand, transmit data as continuous signals. Just like digital systems, they have a transmitter where they modulate the data, a channel, and a receiver while they demodulate the data, but the signals they handle are in the form of continuous waves. Now, let's talk about modulation. Modulation is the process of altering a carrier wave to transmit data. But why do we need it? Well, without modulation, signals can't travel long distances effectively and would interfere with each other. There are different types of modulation, and today we'll focus on three: amplitude modulation, and angle modulation, and radio-digital modulation. In amplitude modulation, or AM, the amplitude of the carrier wave changes based on the information or the modulating signal's amplitude. For example, so as we change the amplitude of the information signal, the amplitude of the modulated signal also changes. It is used in various applications like radios. However, it's more susceptible to noise, which can distort the signal. Next, we have angle modulation. This type includes two main forms: frequency modulation, FM, and phase modulation, PM. In FM, the frequency of the carrier wave changes according to the information signal amplitude. So as you can see, when we change the amplitude of the information signal, the frequency of the FM signal changes. In PM, it's the phase of the carrier wave that varies. FM is widely used in radios and provides better sound quality and noise resistance compared to AM, while phase modulation, though less common, is essential in digital communications and some wireless systems. Digital modulation converts binary data into radio signals that can travel through the air. An important concept here is the symbol. A symbol is a pattern that represents one or more bits of data. They are used to make data transmission more efficient. For example, if 3 bits represent several voltages, we need 8 symbols to describe them, and the rate of the symbols is also known as the baud rate. Let's start with amplitude shift keying, or ASK. In ASK, the carrier wave's amplitude changes to represent binary data. A high amplitude might represent a 1, and a low amplitude might represent a 0. Next is frequency shift keying, or FSK. The frequency of the carrier wave changes to represent data. Higher frequency might represent a 1, and lower frequency might represent a 0. Then we have phase shift keying, or PSK. In PSK, the phase of the carrier wave changes according to the data. Each phase shift represents different bits of data, which means when the digital signal changes from 1 to 0 or 0 to 1, the phase of the modulated signal changes with it. A special type of PSK is quadrature phase shift keying, or QPSK. In QPSK, each symbol represents 2 bits of data by using 4 different phase shifts. This allows more data to be sent efficiently. Lastly, there's quadrature amplitude modulation, or QAM. QAM combines changes in both amplitude and phase to represent data. This method can encode multiple bits per symbol, making it very efficient. These digital modulation techniques are used in many devices we use daily, like smartphones, digital radios, and Wi-Fi. In this video, we have learned the modulation process and its various types: AM, FM, PSK, FSK, QAM, and there are many other types of modulation to transmit signals over long distances and minimize the size of the antennas, because the frequency is inversely proportional to the wavelength. Thank you for watching the video. Hope you learned a lot from it.